the role of the level of legumes in the crop sequence for the reduction of greenhouse gas emission. But we can also use other species for other services, such as here hemp for a high weed suppression ability, or species added for a specific value chain for a high added value. But it's not sufficient. Another key ingredient is the use of compensatory strategies to increase and secure yields while providing different services. I will explain this idea here, because when we have a new species, we can have new ecosystem services, but also sometimes low yields compared to the other species already present in the current system. And sometimes it's also difficult to obtain high yields because of a lack of knowledge and expertise of these new species. In our network, it was particularly the case with grain legumes, with half of the situations with yields lower than 1 ton per hectare. So it's good to insert legumes for nitrogen provision, but it can reduce yields at the crop sequence level. So it's important to have other measures, such as multiple cropping to increase yield per year with the addition of another species within a growing season, or intercropping with the addition of a crop to have an additional yield. So it's a way to increase yield both in time and space with these compensatory strategies. So an example here, with an example we have already seen before, starting from maize monoculture, and the addition here of multiple cropping with an additional yield here with oats before maize. And also additional benefits of this strategy, because we have a higher soil coverage and associated services such as the reduction of leaching and a higher weed suppression. Another example here with intercropping to secure yields, with this example already seen before in organic situation. So the reference system has only soil crops, but in the diversified system we had intercropping. So you can see the additional yield provided by intercropping compared to, for example, here, fava bean stock crops with very low yields. And with intercropping, we have seen in our networks that we can also have additional services, a higher weed suppression, a higher protein content for the cereal, a reduction of lodging, and a reduction of pest damage. Another major ingredient, it's necessary to have a system approach, because it's not possible to maintain this relation with one problem or one objective and one solution associated to this problem. We need to move to a more system approach. So, but we could have the same idea. I want to increase the nitrogen provision. I will insert legumes in my systems. But with legumes, it's not so easy, because we can have low yields, high weed infestation, because legumes are not very competitive against weeds, low crop establishment, and risk of diseases if we have a high level of legumes in our system. So it's, and our first objective, nitrogen provision, can be also impacted by weed infestation, for example. So it's important to have a systems approach to use the diversity of species of legumes to reduce the risk, and to adapt to the system to put the legumes in good situations, and not to see only legumes for the services they can deliver for the other species, but also to see the systems to help the legumes. And to use different ways to insert legumes, not only in soil crops, but also with intercropping, undersowing, cover crops, to maintain the benefits and reduce the risks with legumes. Another example for the systems approach, for the management of weeds, the main strategy in simplified system is to use herbicides, but in a diversified system, it's not possible to have only one unique solution. We have to use different strategies, And it's important to combine these strategies to maintain high weed control on the long term and to face different risks, because some strategies are dependent on climatic conditions, so it's necessary to use a range of strategies. And the last point is, as explained before by Antoine, is adaptive management. So diversification is a non-linear pathway, and different sources of uncertainty can affect this pathway. So climate and biotic factors, extreme events can require to change our first plans, and also the availability of knowledge on a new species, for example. And also some practices are very dependent on climate conditions, so the site-specific character of agroecological practices is also to be taken into account, and it requires an adaptive management, so it's a learning-based process, and to improve the understanding of the system by the monitoring of these strategies, and to improve the benefits and reduce the trade-offs and reduce uncertainties. And also to take the external factors such as regulations, markets, and this evolving context, including climate change. So it's not possible to fix everything at the beginning. So thank you for this attention, and now I will move to different testimonies, and I will ask Raj, Dirk, Aude, and Aline to come here. And Dirk, you are field experiment leaders. Yes, we will start with Raj. Raj from SLU in Sweden. And Raj, I have a first question for you. You are involved in designing new systems, new diversified systems, and you are in an organic situation. So perhaps in the audience we have the feeling that in organic situation it's already diversified, so nothing to do more, but you try to diversify more. So in your experiments, so can you explain why you want to diversify more, and what are the benefits you obtain with this diversification?
Can you hear me? Yeah. Yes, the system is quite diversified. As you can see in the crop rotation, we have 6 years of crop rotation in a reference system in south of Sweden. But if you look at the crops per se in this crop rotation, then we have very high value case crops like winter oilseed, winter rye, winter wheat, which requires very high external organic inputs, and these organic inputs are very expensive and also difficult to get. So one of the idea was how could we reduce this external organic fertilizer input in this system, and we have come up that this could be in time by intercropping with nitrogen fixing legumes or with cover crops, which can be including both legumes as well as non-legume crops. And also, if you look at the crop rotation, another important challenge in an organic system is the weeds, as Gunil has said. And winter oilseed red, I mean, they are grown with very wide row spacing. So the weeds, they just thrive on this between rows, between the crops. The same with the spring peas. They are very, very weak in competing with the weeds. So we also thought that if we intercrop with either faba beans, frost-sensitive faba beans, or as a case crop, which is the barley with spring pea, instead of the weeds, we will be growing crops, which is either a case crop or a service crops. So those were the two ideas that we had in terms of diversifying in space. But then also, if you look at the crop sequence, we see that we have many spring sown crops. And these spring sown crops, for example, oats or pea, they are grown after the harvest of winter rye and winter wheat. And these crops, winter rye, winter wheat, they are harvested in July or beginning of August. And the next crop, they are sown in April. So there is a gap of about 8 months in which the soil is left bare. And it is also during this time in Sweden we receive this heavy precipitation and there's a lot of surface runoff. So why not we have a service crop, cover crop, that will not only increase the health of the soil, but will also prevent the leaching or the loss of nutrients, so that if we could save those nutrients, we could reduce the inputs, the nitrogen input. So when we're designing the diversified system. So what we have seen is that when we reduce the nitrogen input by about 100 kilograms from 270 to 175 kilograms nitrogen per hectare per rotation, in this rotation, we obtain similar or even higher crop yield in the diversified system. And also, if you see the widths, the horizontal bar diagrams, sorry, the vertical diagrams, also see that the crops like winter oilseed rape and spring pea, the widths are strongly reduced when we intercrop with either legumes or even with cereals. The fourth aspect that we had also is that in Sweden there is a growing demand of plant-based protein, and we have more than 20% of the young people who are vegetarian and they want locally sourced proteins. And we thought this is also an opportunity where we could increase the production of our local grain legumes for human consumption. So we have incorporated blue lupins as a crop to increase the number of crops in the rotation, and also able to have the farmers have a diversified income resources in order to spread out the risks. But of course not everything is rosy, not the diversified systems. We also had a big challenges the first 2 years that we look at it, many of the crops, they failed. You look at the economic calculation, it was a disaster. But with time we see that the last 2-3 years, we have adapted the different seeding proportions, different management practices. And I think the soil fertility has also built up during this time, and we see that there is an improvement in the yield of the crops in the diversified system. And I expect to see more and more better results in the diversified system. That's it from me. Well, Dick, I also know that you explored a very innovative crop diversification strategy, that is the strip cropping, which is not well known to many people in Europe. So how has your experience been? Is it a successful? Why and what are the important what do you call it, services that you have obtained in your research? Could you share a few minutes of your experience to the audience?
Thank you, Raj. Yes, first your question of success. It depends, of course, how you measure success. But if you see the amount of uptake by farmers, we have about now 50 farmers practicing strip cropping. So that's a success, and also in policy it's well connected. But I wanted to talk what other services did we find out. And so in the Netherlands we really find the field to strips which are wide enough to allow independent management, but narrow enough to facilitate ecological interactions. And what we found out was basically that depending on the objectives you have, you can determine your strip width. And the more narrower you get, the more ecosystem services you can stack, but also the more complex it gets for a farmer to implement. So that's what we did at Permanent, also what farmers like okay, depending on, they can choose their level of complexity, and they get more ambitious over time. And I think that I forget one ecosystem service, or maybe it's not ecosystem service, but something that's very important with crop diversification, is that farmers experience more joy. They go more often to the field, they see that plants grow differently, they are a true farmer again. And that makes them, gives pleasure in their work, and they continue to improve. So there's no one solution, as Kenny well said. It's really depending on the farmer, what are their objectives, and then we can start designing them.
Thank you for your valuable input, and I wish you good luck with your continued research and hoping to see more farmers adopting strip cropping in the European agricultural landscape. Thanks a lot. Hauke, you conducted field experiment in Germany and also organized a very interesting this regional conference based on the results that you have obtained in your study. And I think the conference was focused on the ability of the diversified cropping system to deliver services. Would you want to share an important message from your conference?
Yeah, of course. So one of the principles we had in Double Impact was to do better things instead of doing things better than it was done previously. And of course, for itself, it's a quite good goal, but it breaks a little bit when it comes to practice. So crop diversification with all the different strategies, of course, is one of the best solutions we have to tackle the objectives for the moment. But it does not work out on its own in most cases. We still need to do things better and to do these things in the right way to to fulfill our targets. One of the examples we discussed in the regional conference and also we experienced in our field experiment is the use of undersown grasses. In general, they fulfill a quite big role when it comes to prevent nitrogen losses into the water and to stop soil erosion. And also, they're in a quite great spot when you have no opportunity to grow conventional catch crops because of drought situations after the harvest or other circumstances. In one of our crop rotation field experiments, we diversified the shown crop rotation mostly with the undersown grasses, and we could observe quite good results regarding the nitrate leaching and the nitrogen uptake of the underground soil grasses, as well as the resilience due to heavy, difficult weather conditions, especially in 2019. But also, if you compare the yields here in Spring Valley 2017 between the normal rotation and the diversified system in orange, you can see that the undersown grasses even enhanced the yield of the Spring Valley. Also, the quality was quite better. So it seems to be the best idea to just use the undersown grasses as often as possible. And also, if you see, you can save nitrogen because you can score higher yields in the diversified system. But even in situations where more nitrogen is available due to whatever may happen, you can score higher yields and also have the benefits of the undersown grasses. But unfortunately, this is only one side of the medal. Not only in our experience, we observed increasing problems with the destruction of the grass turfs and the appearance of wire worms. So also in practice, the sole and common use of undersown grasses caused more problems, as highlighted in the regional conference. In many cases, additional pesticide applications are needed since you have to destroy the undersown grasses before sowing the next crop, and also to get rid of the grasses in the current or in the next main crop to avoid any competition. So with the reduction of available herbicides and we need an intensified tillage system as the only real remaining option for this. But this not only increases the fuel consumption but also the time consumption and has quite serious drawbacks on the soil structure and soil life. So to minimize the risk and trade-offs here, it is really necessary to improve the things, the way we do the things. First, we could further improve the positive effects of the undersown grasses by changing tillage regime towards no tillage or strip tillage, as shown in the first picture. Second, we need to question the way we diversify here. Couldn't be a catch crop prior to a sensitive crop like potatoes be a better solution than the undersown grasses, just to minimize the problems during sowing and also to reduce less beneficial material for the spread of wire worms. From what I know today, these two options could be a solution to the current problems, but they are following very specific questions to answer to really determine if we are improving the system or if we don't. With that said, I would estimate that the focus on the highest possible diversity indicator is not the optimal way, since a well-suited and smart-designed management strategy in a diverse system will perform better than a system designed to foremost as diverse as possible, but does not take the impact of specific management options into account.
Thanks a lot. Thanks for sharing your experiences and also improving along the way how the diversified system should be further improved via practice. Thanks a lot, Hauke. So far we have heard about the strategies of different crop diversification and its effects at the cropping systems level. However, if we change the level of the systems from cropping systems to farm or at regional level, it can boost the delivery of services, but can also pose challenges as well as, questions for its relevance or irrelevance in the existing socio-technical context. Aline, you have been a field experiment leader and you have organized a regional conference with a focus on protein autonomy in France. You see diversification as a lever to reach a larger objective at the regional scale. Can you explain the different strategies that you have investigated in the region in order to reach these objectives? What were the different challenges? Thank you in advance.
Yes, thank you. I would like to focus on two initiatives to promote the protein autonomy through diversification strategy. We worked at the farm level, but also at the territory scale. At the territory scale, the first example is the work we've done with an EIP operational group who recognize local actors in the development of a new value chain of soybean for poultry and dairy production in substitution of imported soybean. It's not only a development at the farm scale, even if we have to farmers have to learn how to produce this new crop in our specific context, but it's also a question at the territory scale with a large number of new producers who have to grow this crop for supplying a soybean processes plant, and that imply interest for them, agronomic ones, but also economic and environmental ones also. So this project also asks about the introduction of soybean in the current rotations of grains farmers, but also of cattle farmers, taking into account the other existing value chains and also the cattle requirements such as forage production or silage maize production for the dairy cows. Second example is the development of intercropping of cereal and legume. As presented before, it's a very interesting strategy. Farmers are using it for reducing yield variability and also providing a new source of protein for feeding. But to facilitate their introduction in cattle rations, they sometimes have to be sorted. And so collective investment between farmers at a territory level is a way to foster these intercrops. For example, in our region, we have several mobile unities for sorting this intercropping, which have been bought by CUMA, Cooperative of Use of Agricultural Equipment, and which gather farmers in a small territory. So we have a third example, and I would like to give the floor to my colleague.
Thank you. Yes, the third example is also at the territory scale with our case study in Pays de la Loire, in the west of France, which were based on cooperation partnerships between cereal farmers and livestock farmers. And the 3 points, the 3 conclusions of this case study can be the first one is about the cereal farmers who could have been they made some diversification because they found some outlet in their neighborhood with the livestock farmers. So it's quite easy for them if they can find some livestock farmers around them. It's quite easy for them to integrate new crops, new protein crops, for example, in their rotation. And these cereal farmers were very happy with those partnerships. And the second point is about the livestock farmers. It's not as much easier as the cereal farmers because they had to integrate protein crops in their feed, in their ration for the cattle, and it's not very easy for them. And so the exchanges or the partnerships that were made were between cereal farmers and livestock farmers who were in the kind of research of autonomy, protein autonomy. So that's quite limited. And the third point is about, it's not a technical point or agronomic point, it's a social point. Even if the first partnerships are based on economics between the two farmers, if we want the partnerships to be sustainable, they had to have a good confidence in each other, good trust, and it seems very important to have some partnerships who can last. So that's it. Thank you.
Thanks a lot, everyone. A lot of inspiration from Dirk, so I approached him last year and we applied for funding from the Swedish Research Council for strip cropping, and we got funding for 4 million Swedish crowns, so strip cropping will also come to Sweden now. Yeah, over to you, Gunel. Gunel will present the concluding slides, and afterwards we will have a question and discussion. Thanks a lot in the panel for the discussion and answers. Thank you.
Thank you. So, just a quick conclusion. So we have seen this is first session, the interest to combine different strategies in time and space. And yes, successful strategies are characterized by the introduction of minor crops, delivering higher ecosystem services while maintaining well-mastered major crops, associated with compensatory strategies. It's a dynamic process requiring a system and an adaptive management. We have also seen in these testimonies the key role of crop management of such systems and the adaptations with the actors to find best solutions. So we have seen ingredients at cropping systems level, but yes, this potential is not fully exploited at this stage today, as it has been explained by Antoine at the beginning, because current cropping systems have benefited from research and development efforts carried out over decades, but less efforts for diversification, for example, lower genetic progress on minor crops. So, and the social technical lock-in, it's also a key component with mechanisms of self-reinforcement. So there is a potential, but also other ingredients needed at other scales than only cropping system level. We have already discussed this with the testimonies, because at a larger scale it's also possible to gain benefits with common objectives at a regional scale, such as the protein autonomy, but it's also important to remove barriers at different scales or to take new market opportunities, also the coordination of actors, policy support. All these ingredients are also essential, and also the use of relevant tools to assess and guide actors, and the development of new actionable knowledge. The question also of metrics, the assessment of diversification depends on the metrics we use, so it's another key point. And all these points will be discussed in a following session to go more than the cropping system level. So thank you for your attention, and we have now time perhaps.
And I have a question about the Kuma and the machine that is shared between people. How many farmers do share this machine, and what is the surface of the region? Or yeah.
We have different organization. It depends on the scale of the territory. In some example, it's about 10 farmers who share a sorting machine. But it depends on their use. Before